We continue with Bohr's atomic model. We completed the postulates last lecture, people, and we'll now do numericals. Okay. Chalo. Now, the first question that we have over here, people, is the energy of electron in Bohr's orbit is minus 2.18 into 10 raised to minus 18 joules. Okay. Though they've directly given us the value, let us quickly recollect what was the formula for energy of the electron in Bohr's orbit. Energy of the electron in the nth Bohr's orbit. Anyone remembers the formula? Minus 2.18 into 10 raised to minus 18 into z square over n square joule per atom. And the same formula in electron volts. Anyone remembers in electron volts? Minus 13 points. Excellent. Into z square over n square electron volts. So even if they would have not given that data, that the energy in Bohr's orbit is this, हमें पता होना चाहिए वो. ठीक है, रिपीट अगर नहीं दिया तो भी we should know how to find that. हमें पता होना चाहिए कि हमें उसे कैलकुलेट कैसे करना है. Now, if that is the energy, तो हम उसको E1 लिखते हैं. So E1 they've given us is how much? Minus 2.18 into 10 raised to minus 18. Energy in the third orbit. Third orbit, what does that mean, people? So we have to find E3. So what will you put that formula mein? Minus 2.18 into 10 raised to minus 18 into. Now they have not specified, so we'll consider Z to be as 1. So that will become 1 square over into 1 over 9. And this is, people, the energy in the first orbit. With me? So energy in the third orbit will become how much? 1 upon 9 times the energy in the first orbit. Everyone got that? Any questions यहाँ पे? So यहाँ पे answer क्या है, people? 1 over 9 times. ठीक है? That was थोड़ा सा easy. Now let's look at this one. The energy of an electron in the second and third Bohr's orbit is given by, how much is the energy given? Minus 5.42 into 10 raised to minus 12 ergs. Now, ergs ka, we can, if required, convert that into joules. Anyone knows the erg to joule conversion? 1 erg is 10 raised to minus 7 joules. Okay? Such conversions usually exam में भी अगर जरूरत है, they'll give you that in the exam, in the paper. So the energy of the electron in the second Bohr orbit. So they've given us E2. How much is the energy, people? Minus 5.42 into 10 raised to minus 12. Can I write that in terms of joules as 10 raised to directly minus 19 joules? And the energy in the third orbit, how much is that? E3, negative 2.41 into 10 to the power, again minus 19 joule. ठीक है? What is the question? But calculate the wavelength of emitted radiation when the electron drops from the third orbit to the second orbit. Now, if you remember last class, let's say an electron is present in an inner shell. If you supply that electron energy in the form of a photon, it goes from a lower shell to a higher shell. This was called as excitation. While writing one of the Bohr's postulate, हमने ये लिखा था. when it goes from a higher shell back to the lower shell, it releases a photon. That was called as de-excitation. So यहाँ पे that during that de-excitation, when an electron drops from the third orbit to the second orbit, that photon which is released, you have to find the wavelength of the photon. With me till here? What you need to first understand, people, over here is we need to first find the energy difference, which we did calculate जब हम Bohr's postulate भी कर रहे थे. अब energy difference यहाँ पे find करने के लिए they've directly given us the energy difference value. So I need to first find the difference in the energy levels dropping from the third to the second orbit. So that will be E3 minus E2. How much is E3 given? Negative 2.41 into 10 raised to minus 19 minus, how much is E2? Negative 5.42 into 10 raised to minus 19. Minus into minus, ये क्या होने वाला है? So that will be minus 2.41 into 10 raised to minus 19 plus 5.42 into 10 raised to minus 19. Can I write this as, if I take 10 raised to minus 19 common, 5.42 minus 2.41 into 10 raised to minus 19. How much that becomes? How much is delta E? That is 1, 0, 3.01 into 10 raised to minus 19 joules. So this is the energy gap between the third orbit and the second. Yahan tak with me? Yes or no? But what we have to find is what was the wavelength generated. So what is the formula for energy of a photon? It is how much, people? hc over lambda. How much did we get delta E over there? 3.01 into 10 raised to minus 19. H and C, how much is H? 6.626 into 10 raised to minus, how much is C? Over lambda is what we have to find. Thoda sa, let's approximate this. Instead of writing 3.01 into 10 raised to minus 19, हम क्या कर देंगे इसको? 3 into 10 raised to, anyone remembers this multiplication? 6.626 into 3? Excellent, that was 19.8 into 10 raised to minus 26 over lambda. So how much is lambda, people? 19.8 into 10 raised to minus 26 over 3 into 10 raised to minus 19. Can you solve this for me and finally find lambda? कर सकते हैं इसको? चलो जल्दी जल्दी तेरे को करना पड़ेगा ये, ठीक है? Okay, so the answer for lambda or the wavelength of that particular photon, the answer should be somewhere around 660 nanometers or 6600 angstrom. Chalo. Now I've written one more statement based question. Okay, so we get entrance exams में statement based questions where you need to identify whether the statement is true or false, correct है या incorrect, or they might ask assertion and reason type question. Assertion and reason means they'll give you a statement और उसका reason देंगे. You need to identify whether that reason is the right explanation for that particular statement or not. तो ऐसे अलग अलग type of statement based questions वो पूछते हैं. Now let's read the first statement. What does the statement say? According to Bohr, the magnitude of velocity of electron increases with decrease in charge on the nucleus, as there is no strong hold on the electron by the nucleus. First of all, can anyone tell me what was the formula for velocity? Velocity of electron in Bohr's orbit? What is the formula for velocity of electron in Bohr's orbit?
2.18
Z over n meters per second. Excellent. तो हमने formula क्या लिखा था people वो? The formula we had derived was that velocity is equal to v naught into z over n. हमने इसका formula derive किया था. So can I say that v, a velocity, is directly proportional to z over n? We know that v naught is a constant. What is z over here? Atomic number. So can anyone tell me, as the atomic number increases, will the charge on nucleus increase or will it decrease? I repeat, as the atomic number increases, there will be more protons present inside the nucleus, and hence the charge on the nucleus will increase. Yes or no? So if the charge on nucleus increases, basically if z increases, then what should velocity happen? What should happen to velocity? Velocity को क्या होगा people? Velocity भी increase होगी. Yes or no? Direct proportionality ना दोनों में. आप न्यूक्लियस पे चार्ज बढ़ाओ, which means और प्रोटॉन्स हैं न्यूक्लियस के अंदर, there are more protons inside the nucleus, which means the charge on nucleus will increase. न्यूक्लियस पे अगर चार्ज बढ़ता है, what will happen to the velocity of the electron? That will increase. But यहाँ पे statement क्या बोलता है people? The magnitude of velocity increases with decrease in charge. Is this statement correct or incorrect? Statement is incorrect. Now read the second statement for me. Second statement क्या बोलता है? The magnitude of velocity increases as the electron moves. Excuse me. Away from the nucleus. What does that mean? Moves away from the nucleus. n का वैल्यू क्या हो रहा है? पहले न्यूक्लियस के नजदीक, मतलब n is equal to 1, then 2, 3, 4. So न्यूक्लियस से दूर जा रहा है, and velocity और n का क्या रिलेशन है people? Inverse proportionality. V is inversely proportional to n. So if n will increase, मतलब दूर जा रहा है, तो velocity को क्या होगा people? Velocity will decrease. Now let's read the statement again. The magnitude of velocity of electron increases. Magnitude बढ़ता है velocity का as the electron moves away from the nucleus. ये statement true है कि false है? That statement is correct or true. Anyone who did not get that? Yes or no? Chalo. Let's move on to the next question. Select the correct plot among the following. The first plot is between people velocity and orbit number, radius and same orbit number, potential energy 1 upon n, kinetic energy in n. How do we decide these plots? Again, we need to know the Bohr's formulas. Velocity and n का अभी हमने देखा है. What is the relation between v and n? V is inversely proportional to. So if v will increase, n has to decrease or vice versa. यहाँ पे क्या हो रहा है? As n is increasing, v भी क्या हो रहा है? Increase हो रहा है. This plot is incorrect. I think basic mathematics में you people must have done plots or graphs. To get a graph like this, what is the actual equation of the graph? A line passing through the origin, y is equal to mx जैसा plot होना चाहिए. So if I plot velocity versus z, I will get this plot. So instead of n, यहाँ पे क्या होना चाहिए? तो then the plot would have been correct. Z. With me? Second, radius versus n. What is the formula for radius of Bohr's orbit? R is equal to xln 0.529, उसको मैं r0 लिख देता हूँ, into n square by z. Yes or no? अब r and n में relationship, r is directly proportional to n squared. Yes or no? This plot is correct. This, let me explain this, then put it out करते हैं एक साथ. Next, potential energy. What was the formula that we did for potential energy? What was the formula that we derived for potential energy? Go to Bohr's postulates. Potential energy and kinetic energy का formula देखो हमने क्या derive किया था. पोटेंशियल एनर्जी का फॉर्मूला हमने क्या डिराइव किया था? K. Q1 Q2 तो जनरल फॉर्मूला है पूरा. Q1 की जगह पे हमने सब्स्टिट्यूट किया था ZE K ZE square upon. Yes or no? Was it positive or negative? Was a negative here. With me? Now if I look at the formula for potential energy, ठीक है, let's do this थोड़ा सा next page पे वापस से. What is the formula for potential energy, people? K Z E square over, and if I look at the plot which we have drawn over there, वो है potential energy versus 1 over n. ऐसा बनाया वो plot. There's nowhere यहाँ के formula में do you see anywhere n? Yes or no? There's no n. But we can find or we can replace a particular quantity by n. R can be replaced by, what is the formula for R? R naught into n square over. Yes or no? Put that here. Potential energy is equal to kz E square over. Instead of R हम क्या लिखेंगे people? R naught into n square over z. ये z किधर जाता है? That goes up here. So what will now be the expression for potential energy? K z square E square upon R naught into 1 over n square. I forgot the minus. Yes or no? ये पूरे term is actually a constant, and we get potential energy is proportional to 1 upon, remember there's a minus over here, getting that, and hence this plot is did you people get that? I want you to try exactly the same for the final KE. KE का formula क्या था people? Half of that, half of this exactly. Yes or no? K Z upon, same R की जगह we can replace that by R naught into n square over z, and you will try if you get this particular plot. Just a sec. In the first numerical, we please change this to incorrect. ठीक है, I did a small mistake. ठीक है, तो यहाँ पे instead of correct the statement is incorrect. velocity is inversely proportional. So the electron, as it moves away, what will happen to the velocity? It will decrease. Also, 2 homework questions. Complete this and we will discuss this next class. Okay.